Welcome. This is 8.3 on circle basics, and we're going to review some things that hopefully you know. Maybe introduce one or two things you don't know. So, first of all, circle is defined as being the set of all the points that are equidistant or the same distance from a fixed point, and that fixed point is called the center. Which leads us to the next definition. The radius is the distance from the center to any point on the circle. So you might mark it like this. This distance we would call the radius. Also, usually we use the variable r to show that it could be any number there. A chord is a line segment with both its endpoints on a circle. So a chord looks like this. Just a line segment. And diameter is a chord with both its endpoints on the circle. So it always goes through the center. It's the longest chord in a circle, and that is the diameter. The diameter, we use the variable d to represent diameter, and the diameter is equal to the radius times 2, or 2r. Our diameter is equal to 2 times the radius. All right, the circumscribed in a circle, a polygon that is inside a circle and all its vertices are points on the circle. So it might look like a triangle, like that, or it might look like a quadrilateral, something like that, or any number of points that you want. But if it's inside the circle and the points are on the circle, then it is said to be inscribed. It's inside the circle. Circumscribed, not inscribed, circumscribed. All right, a tangent line is a line that intersects a circle at exactly one point. A tangent line touches the circle just at one point, and that's it. So that would be called a tangent line. The tangent line is perpendicular to the radius at that point. And so if this is the radius, then these two lines would be perpendicular to each other. Secant line is a line that intersects a circle at 2 points. So if we have a line that goes through, not a chord stops on the circle, but actually a line and it crosses through at 2 points, then that is said to be a secant line. Couple notes. Figures that are similar have corresponding parts that are proportional. To prove that a circle is similar to another circle, you will need to prove that their corresponding parts are proportional. For example, their radius, their diameters, their circumferences. Figures that are similar to one another are also dilations of one another. The dilation uses a center and a scale factor to create a proportional figure. The ratio of the corresponding parts is the scale factor of the dilation. Okay. So just very briefly about that, like if I had a circle and its radius was 1, if I had another circle and it was radius 2, then the scale factor would be 2 to project that smaller circle onto the bigger circle. Okay. We'll see you in the next video.